more example. Uh, Otherwise, what we'll do is we'll go to the next this thing. We'll go to the next what do you call next this thing. Okay, Shagnik, you leave it, and now madam should start this thing presenting. Shagnik, you leave your this thing presentation. Madam will start. Madam, please again share your screen and go to the second slide. No, the second one, the third one. Sorry, third one. Okay. Now full screen. Fine. So what has happened during the COVID? No, it taught the humankind multiple different things. It also taught that there is a desperate need of integrating this thing, computer science in biomedical research. Now this is a very good example of very easy to understand, very nicely designed, and what shall I say, state of the art technology. Now what they have done, they have done a very small thing. They have produced that data set of two things. One, COVID infected lungs, MRI or CT. COVID or X-ray is also there, I think. Yes. COVID infected lungs and non-COVID infected lungs. Okay. So it may sound very gross. Why it may sound very gross? Because it may happen that if you are just stuck with COVID, your lungs has not yet been infiltrated by multiple cytokines. Okay. Now in the chat box, somebody should write down whether you have come across the terminology cytokine storm during the COVID days. If anybody has come out this particular terminology, they have heard cytokine storm. Is there anyone who have heard about this cytokine storm? Anybody is there who have heard cytokine storm? Yes, this is by Shayak Mandal. Acha, anybody else? Okay, very good. Obeidi also. Okay, now coming back. Now cytokine storm is the inflammation which causes the destruction of the lungs or complete fibrosis of the lungs. Why fibrosis means what? Losing functional tissue with some filler. Okay, some unnecessary this thing. So why this thing happens? When the COVID-19 takes place after certain time period and after certain viral load, there should be sufficient viral load also. What exactly happens is your lungs is infiltrated by multiple different cytokines. They basically try to save your lungs, but while doing so, they do a collateral damage. Okay, now what was the idea? The idea was to kill the virus or the virus infected cell and to protect your lungs. But while during this thing, what they do is they eventually destroy the lungs and make large scale fibrosis in the tissue. And so the lungs become fibrous, and everybody, whenever they'll look at it, they'll understand by CT as well as X. But it will take a little time. Understood? So this particular technology is very useful where they are using what? Artificial neural network. Okay. Now, what is artificial neural network? I'll show you a snippet in the next day, not today. So consider that you are having an algorithm which can identify the digit 8. So what will be the training set? The training set would be some digits or some patterns which looks like the digit 8. Okay, now digit 8 means which digit 8 you know. Previously, when we were young, there were some digital watch where they used to use like 5 or 1, 2, 3, 4, 5, 6, 7. 7 or 8 bars to display any digit from 1 to 0. Okay, remember? Now you have to train your algorithm to identify the digit 8. Now what can go wrong? Now digit 8 and digit 0 many a times look similar. Only there is a middle bar. If the middle bar removes, the digit 8 becomes digit 0. So many a times this artificial neural network eventually identifies a wrong positive. Okay, false, we call it false positive. Okay, because you have not trained your algorithm well. So there is a huge possibility. This is the drawback of artificial neural network. Therefore, it needs huge amount of data. Okay, in the contrary to support vector machine. In support vector machine, it is very rigid. Okay, eventually, instantly, it will identify whether it is 0 or 8. Okay, but artificial neural network it cannot do, but it's very flexible. It takes very less amount of time. So they used it, and this was showing very good demonstration, but in practice it was not this thing. What do you call? It was not this thing. What do you call? Not very successful. Okay, it was giving some bad predictions. Okay, so that was the limitation of artificial neural network. We will also use an algorithm which will show you artificial neural network how it uses in biomedical research. So I just wanted to show you that artificial neural network, we will come back to this thing again. So as you can see here, what it does is it identifies pattern on the basis of the training set. It is similar only, but here what happens, multiple different layers are there. So in the first layer, you give a digit 0. In the next layer, you give digit 8. In the next layer, you give digit 0 and 8 together. Then in the next layer, you give 0, 0, 0. Then in the next layer, you give 8, 8, 8. Like this, if you increase